Good afternoon, all of you. We are starting a new chapter today, which is thermodynamics. Thermodynamics is a very important chapter in your syllabus, so please pay good attention for better understanding. So, the word thermodynamics consists of two different words, which are thermo and dynamics, and that itself tells us about what we are going to study in this chapter. So thermo means heat or heat energy, and dynamics means motion or flow. So we are going to deal with thermodynamics or flow of energy. So flow of energy is what we are going to study in this chapter. Thermodynamics is a field not only linked with chemistry but is also involved in physics. But in chemistry, thermodynamics deals with the chemical energy stored by molecules and can be released as heat energy during chemical reactions. So during chemical reactions, the chemical energy within the molecule is being converted to heat energy. So that flow of energy is being studied here. For example, cooking gas or coal burns in air. So when the coal burns in air, the chemical energy which is stored inside the molecules of coal is being converted to heat energy, and that heat energy is used for different purposes. So this kind of energy flow is being studied in thermodynamics. The chemical energy may also be used to do mechanical work when a fuel burns in an engine or to provide electrical energy through galvanic cell like dry cell. So chemical energy is not only converted just as heat, it can be converted to mechanical work. So chemical energy by fuel burns is converted to mechanical work in machines. So this conversions like the chemical is involved where the chemical is involved and energy is produced for different activities. This energy flow is being studied in thermodynamics. Thus, various forms of energy are interrelated and under certain conditions these may be transferred from one form to another as we have seen here. So when the chemical energy is converted to other forms of energy, there is an energy flow and mainly heat energy. That energy flow where the chemical energy is involved is being studied under chemistry of thermodynamics. So that's where the thermodynamics and chemistry is linked between. And this becomes the subject matter for thermodynamics. And we have two drawbacks which we have to tell now of thermodynamics. So the laws of thermodynamics deals with energy changes of macroscopic systems involving a large number of molecules rather than microscopic systems containing few molecules. Almost all thermodynamic systems and laws tells us about macroscopic systems or bigger systems involving large number of molecules. So the laws are applicable only for large number of molecules rather than the microscopic systems with few number of molecules. So that is one drawback, and another is that the thermodynamics is not concerned about how and at what rate the energy transformations are carried out, but is based on the initial state and final state of systems. So for example, this material in the initial state will look like this, and finally after the energy conversion it will look like this. So in thermodynamics we are not concerned about how this material is transferred to this stage. We are just concerned about what is the initial stage, what is the condition of this material at the initial state, and what is the condition at the final state. We are not concerned about the intermediate processes or how it is transferred. We are just concerned about the initial state and the final state. We will be observing and finding out measures from just these two states. But in chemistry, we can prepare same product from same reactant through different methods. So the intermediate state becomes an important factor there. So same reactant and same product but different methods. For example, like the SN1 and SN2 reactions. So there we have same reactant and same product but different methods. And thermodynamics is not concerned about the method, just the initial state and the final state. So this becomes a drawback of thermodynamics in chemistry, but we are not concerned much about this as thermodynamics is able to explain a lot of laws and concepts in chemistry. So moving on, thermodynamic terms. We do have three terms which actually tells us about the processes which are going on. So they are system, surrounding and boundary. We will study them individually. So first we will be studying about the system and surroundings. We will study them together as they are interrelated. So the word system is used for an isolation or isolating the substance which we are observing. For example, in this universe, we have a lot of galaxies. Out of that, in Milky Way galaxy, we have a solar system. And in the solar system, we have a planet Earth. And in Earth, in a country, in a state, in a lab, we are doing a sample. So we need isolation for that particular sample which we are observing. So that particular sample which I am observing is the system for me. And whatever is other than the system in the universe is known as the surrounding. That's it. So the sample which I am dealing with or which I am observing is known as the system. And anything other than that in the universe is known as the surrounding. For example, if I am taking a conical glass full of ether and I am trying to heat it and observing the changes what is happening to the material. So that ether which is contained inside the bottle is known as the system for me. Anything other than that in the universe is known as the surrounding for me. So that's it. So the system and surrounding. A system in thermodynamics refers to the part of universe in which the observations are made. So if it can be a gas, it can be a liquid or it can be anything which I am observing, that is the system for me. So we tell the word system for an isolation. I want to isolate the thing which I am observing from the rest of the universe. So that's why I tell it as a system. And whatever is remaining in the universe other than the system is known as the surrounding. Whatever in the universe except my system is known as the surrounding. Or the surrounding includes everything other than the system. That's what we told just now. System and surroundings together constitute the universe. So surrounding is universe minus system. Right. So surrounding, I told, whatever things are remaining in the universe other than the system, that is surrounding. So surrounding is universe minus the system. So we can tell universe is equal to system plus surrounding. Right. So the surrounding is universe without the system. Hence we can tell universe equal to system plus surrounding. So the system and surrounding constitute together the universe. For example, if we are studying the reaction between two substances A and B, which is kept in a beaker or a conical flask or anything. So the beaker containing the reaction mixture is the system and the room where the beaker is kept is the surrounding. Even if we tell the whole universe, in thermodynamics we consider just the near surroundings, because in thermodynamics we speak about the thermal flow or the energy flow, and the energy flow from this particular sample is possible only inside the lab, right? So the energy flow, for example, if I am heating this and the heat energy from this will go only to the lab, right? So it will not go to the entire universe. The entire universe can be considered as the surrounding, but unless or when we take the sample, we consider just the near surrounding as my surrounding. So when I take sample A and sample B in a beaker or a test tube, that is my system, and the room which I am standing is the surrounding, so that the change of energy is just between the room and my sample. And one more factor is, for me, the A plus B sample is the system, and for another person who's experimenting with other things, for him that is the system, and including me and my sample becomes surrounding for him. For example, if a person is observing this test tube here, inside the test tube he have kept something, so that is the system for him, and rest everything including my sample and me, that is the surrounding for him. So sample and system is depending upon the consideration which we have. So the next thermodynamic term is the boundary. From the name only you can make out what it is. So it is necessary to think of a system as separated from the surrounding by some sort of wall which may be real or imaginary. The wall that separates the system from the surrounding is called as the boundary. For example, I am taking a conical flask and inside that I am taking a water. So some amount of water I am taking and that I am considering as my system. So the system, if I want to heat it, how will I heat it unless it is having a boundary? So the boundary is the conical flask here. So out of the conical flask is the surrounding. Inside the conical flask is the system. So that separation between the system and surrounding is called as the boundary. So the separation between the system and surrounding is known as the boundary. It allows us to control and keep track of all movements of matter and energy in and out of the system. So if I am heating it and I want to know whether the heat is going out or staying inside this flask. So unless there is a boundary, how we will understand that whether the energy or matter is flowing out of the system or not. So such kind of things are done by the boundary. So boundary is very much in need in the thermodynamic processes. So the universe and the system. So the system and universe is being separated by system boundary. Now we will study about types of systems. We do have three types of systems, which are open system, closed system and isolated system. In that, first we will study about the open system. In an open system, there is an exchange of energy and matter between system and surroundings. For example, if I consider a glass full of hot water, I can tell it's an open system. So this is my system and outside the glass is my surrounding. And there is exchange of energy and matter between the system and surroundings. Why? So when I keep the glass open for a while, the temperature of this water decreases because the energy or the heat energy of this water is being exchanged with the surrounding. So the heat energy inside the water is being lost to the surrounding. So that's why the temperature of the water decreases. So I can tell energy is being exchanged with the surrounding. It is not kept inside the system. It is going outside the surrounding also. And about the matter. So if I keep hot water inside the glass, evaporation happens. So by evaporation, the matter or the water present inside my system is going out. So due to evaporation, my matter is also going out of the system. So this kind of system where we have exchange of energy and matter between the system and the outer surrounding is known as an open system. So you can remember this example only. So when I take a glass of hot water and keep it outside, after some time the hot water become cold water as it is exchanging the heat energy with the surrounding, and the amount of matter also will reduce as because of the evaporation. This kind of system is known as the open system. Now what is a closed system? In a closed system, there is no exchange of matter, but exchange of energy is possible between the system and surrounding. That kind of system is known as closed system. So as example, if I consider bottles, so the usual plastic bottles if I consider, that is an example for closed system. So when I keep some hot water inside this and kept it for a while, slowly and slowly the temperature of the water will decrease. As the temperature or the heat energy is being exchanged out of the system, the temperature of the water inside this will decrease. So the energy is being exchanged. But evaporation is not possible inside this as it is closed. So when the system is closed, evaporation will go just till here and it will settle down inside only. So there is no exchange in matter. The water is not going out at all, but energy is going out. That's why after some time the hot water become cold water. So this kind of system is known as the closed system. And now we are moving on to the third type of system, which is isolated system. In an isolated system, there is no exchange of energy or matter between the system and the surrounding. For this, I have an example which is a thermal flask. An ideal thermal flask, if we consider, after 5-6 hours also, if we keep hot water inside this, the temperature of water will not decrease. So that kind of system is known as isolated system, where there is no exchange of matter or even energy outside the system. The water also will not go outside, temperature also will not go outside. So heat energy and matter is properly kept inside. There is no exchange at all. So that's why we can tell it's an isolated system. So open system, there is both exchange of energy and matter. In closed system, there is exchange of energy but not matter. But in isolated system, there is neither exchange of energy nor exchange of matter. So this is the three systems which we have in thermodynamics. It can be represented like this. So in open system, there is exchange of matter and of energy. In closed system, there is exchange of energy with the surrounding. In isolated system, there is no exchange of matter and of energy. You can draw this figure to your notebook. And when you prepare notes, you can give example of the examples which I have given, the open glass, the closed bottle and of the thermal flask. So with this, we finish our today's class. So please go through the textbook and prepare notes. Thank you.